I'm going to make 3 videos about how to completely factor any polynomial. The first video will just contain general information, and the second and third videos will contain examples of completely factoring a polynomial. So, based on the fundamental theorem of algebra by Carl Gauss, Carl Gauss proved that if you have a polynomial with rational coefficients, then the degree of the polynomial, in other words, the highest power, is the number of factors that that polynomial has. So for example, if we're looking at a third degree polynomial, it should have 3 factors, 3 zeros. If you're looking at a 7th degree polynomial, it should have 7 factors, 7 zeros. And they may be duplicates, like a couple of zeros that are the same, but it is definitely true that the degree tells you the number of factors, the number of zeros you're looking for. Okay, so the first thing to say is, well, is the polynomial simple enough that I can just factor it myself using old Algebra 1, maybe Algebra 2 techniques? If so, do that. That's the fastest way. Were you given a hint? Like someone told you one of the factors, or 2 of the factors, or 1 of the zeros, and then you would use that with either long or synthetic division to begin to break down the polynomial. Do you need to find your own hint by looking at the graph and seeing where those x-intercepts are? In the old days, we used to create our own hints using factors of the constant divided by factors of the leading coefficient, and we would create a list that was called the possible rational zero list, and then we would begin to use synthetic division or long division to try each and every one of those until something worked. Your life is better because you can look at the graph and then determine that these possible rational zeros are the ones that I actually want to start with because they look like they're going to work. Again, while you're looking at the graph, did you see something that would indicate that a zero repeats more than once? Like you saw a parabola shape at the 0, or you saw a cubic shape at the 0. Then even though you only have 1 0, you can use it multiple times. And here's a nice little fact. For every complex a plus bi, or irrational 0, like 2 plus the square root of 5, there is also a conjugate for that 0. So again, if I had 2 plus the square root of 5 as one of my zeros, I would also have 2 minus the square root of 5 as a 0. Or complex-wise, if I had 3 plus 4i, I would also have 3 minus 4i as a 0. And then our old friend, the quadratic formula, often comes in right at the end to find us the last 2 zeros that we need. So we're going to be using all of this information to completely break down polynomials.